So good morning. Today we want to have some extra details about TCP, including this one and some extra details for go back N and some finite state machine. And finally, we want to wrap up this chapter. So let us continue. Well, so why I get back to this page, slow start. In fact, this Monday we already have the thin pair share. Thin pair share actually related to the delay modeling of the slow start. And we have some parameters. This parameter, we can have K. Alright, so we can have a K and we can have a Q. And you need to have some derivation based on base 2. Why it's base 2? Because if we implement slow start, we have egg. Then we increase CWND by 1, right? So we will have the base of 2. Why? Because initially we have 1, and because plus 1, so we have a base of 2. And right now, I try to draw your attention to think about this. If I change the increased number from 1, for example, to n, so the base should be, it should be 1 plus n. For example, n equal to 2. Then we have 3 here. Alright, so this one I just want to mention. Why we base on base of 2? Because once we receive 1 egg, then we have 1 plus 1 for the first one. Then you have the way to increase the window size using exponential based on base of 2. If we receive 1, then increase 1. However, if I change it to the general one, n, so the exponential base should be 1 plus n. Alright, so this one is just a reminder. Why? Maybe I try to have the extension into the question, so I should mention this to you. And let's check the others. So for these, I think it's okay. And right now, maybe let me go to this one. We finished the thin pair share, and also I already have the answer there. So first of all, let me check. After the thin pair share, so that serves a supplement, and about that supplement of delay modeling for the TCP slow start, that one. So I want to check your status about your comprehension there. Alright, so I use this directly. This one, I want to make sure everything's okay with you or not. 2 minutes for you. Oh. A larger one? Yes. So after now, I received understood well. That's good. Maybe some of you failed to let me have the response. I'm not sure to have any response or not. Alright, so About this one, I think it's okay. And of course, there you have the solution. The solution, we have two sides. Left side, finally you have the answer there. And right hand side, there you have the reason why we have the calculation. So the calculation are based on some intermediate steps. And there you have the gap. Gap is positive or negative. If it is negative, then we won't have the gap. Set it to 0. Well, I use that one, so I do not use the formula directly. If indeed, okay, you think it's easy for you to apply the formula, feel free to use it. Well, so let me get back to this. So this time I skip the Polar page and go to this one. Yes, we need to wrap up the chapter, so we go through some remaining slides for some extra details. First of all, in fact, in the past, we have the slides when we discuss go back N, but the authors in the new version, they think, okay, don't want to make it complicated, so we have a simple version in the previous slides. However, here we have the center of go back N and shown in the pseudocodes. I think we assume students coming from computer science, even maybe you are not from computer science, but still you should understand the meaning if we have the pseudocodes here. Alright, so you can take a picture and think about if we apply the current go back N version, and think about if we have a time, when it should be the time instant. We set the time, a timer for timeout. So let's check quickly. Maybe I use the current curtain here to make sure. Well, so base, that's fine. We have an initial setting base and the next sequence number. Go back and expect. Alright, so initially we have a 1 and 1, and maybe sometimes we don't have any action. Maybe right now I don't check in detail, but at least you see start timer. So this is the initial one. Based on the pseudocode, we have the initial one base equal to next sequence number. If we start the window, of course, we should start timer. That's correct. However, how about this one? If we have the new one, get it, receive it, not corrupted, so we have the base, we get the new base, right? Because we receive, actually here we have the way to receive, actually it should be X. And so that we can advance. And then, okay, if nothing else, then we should stop. Nothing else, then we should stop timer. Or otherwise, we still have a packet to process. So, at that time instant, we start the timer. Alright, so maybe up to now, I'm not sure you understand what I talk to you now or not. But I make it simple in Chinese again. 一开始如果我们就是第一个 window 的，我们当然要 start timer。我们收到东西，最后我们其实如果没有了，当然要结束但是如果还有，我收到了一个 act， 所以我就要 start 一个 timer。所以我们假想一个1、2，我们现在是2的部分。2的部分，你原来认为是在2送的时候就起的 timer， 不是哦，在这个 pseudocode 是在回到 act 的时候才起的 timer。So here, I just want to emphasize according to the final set machine, when we have the time instant of the timer, you can check that one. I just emphasize that one. As for the receiver, I think you can check it later. So here I want to mention this. If we base on the current one to have the timeout, in the previous discussion for mobile N, we think we will have the start timer when we send packet 0, 1, 2. Alright, 0, 1, 2. But in fact, for the current, if we have the pseudocode for the mobile N for the previous 2 pages, no, it is not the time when we send. So when we have the timer, actually if we have a start timer for 0, and then once we receive it here, it's 1. Here it's 2. So I just want to mention start timer for packet 2 here. And so that you should have the timer, maybe we need to move the previous timings here to the current one, and so that a bit later to have a timeout for packet 2. About the current discussion, I just want to emphasize if indeed we base on that pseudocode, we should modify the current diagram. Alright, so about this, I think I just want to emphasize this one. Maybe you need to take time, or maybe you can revisit the video later, and so that you will know, yes, we should modify the timings for timeout. Timer start once we receive the egg, and then we will start the timer because we need to continue to process the packets. So of course we should start timer there if we have a pseudocode there. Maybe I'll go through quickly, but at least I think you can check it later. I want to mention this one. About the current one, I think because of a limit time, this time I do not ask you any questions. I ask you to check it after classes, and you will know, yes, it's true. So if we have that finite state machine for the sender, we will have the modification for the diagram here. Well, as for TCP, yes, just for this one just provides you the simplified TCP version. I think this version we don't have any further information if we know something in the previous slides. I just want to mention, yes, we have some finite state machine for TCP as well. So you can check it later. And so here we have actually talking about the connection management. So we will have the finite state machine talking about, you see, here we have welcome socket, so it's a server. Alright, so it's client. So we have the client side action and the server side action if we put them together. And normally it won't be necessary to put them together, but we have the two sides to have the corresponding action. So you can check it. I just want to mention we have that one. But I want to emphasize one important thing for closing a TCP connection. In the previous slides, actually I mentioned, yes, we have something like this. But the special one, this one. Look at this. If client initiate close the connection, sure, server will agree. So agree. That's fine. And the server will ask the connection here. So sure, for server, it can close it. But for this one, it should wait. here, wait. Alright, so wait the extra time and so that the client can close the connection. Why? Because maybe server may send some other packet or segment to the client, so the client cannot close it immediately. And that's why we have a suitable time period required for the client to close it once the server initiates the closing a connection. So this one, in fact, I mentioned, but I use the current diagram to let you know, yes, we should have an extra time period to wait before formally close the connection by the client. I mentioned the client side, we should have the extra time period to close it. So these are some extra details I try to draw your attention to notice. And you can check with the previous slides or maybe some of the discussion using the video so that you will know, yes, we have some extra things to do. And here, in fact, we have some problem talking about how to derive the throughput. So if we have AIMD always start from the current version to W/2 to W. And if I want to calculate the average value, average throughput, so what's the value? It's easy. You just have this one plus another one and over 2. So finally it should be this. If we care about the average value, so here we already have the simple calculation. And in fact, we focus on this one. Well, actually, we have some derivation. This derivation included in one exercise. So you can check that one. Because we based on that concept, and so that we want to have some further calculation. That further calculation can let you have this formula. Well, today it doesn't mean I want to derive that formula for you. I just want to let you know this one. So this one, maybe I cannot have any NPAT version for you. So TCP throughput equal to this one. And this one you can pass on the problem in chapter 3 and then you will know how to have the possible derivation. So this one I just want to mention, yes, if we have the formula, then based on that problem, then you will have the formula. If we base on this formula, then you can check this example. Given the size of a segment and given RTT, and here we want to achieve throughput equal to 10 gigabits per second, then follow the formula, it says, well, we should have the window size extremely large. Extremely large, then we'll have a really low loss rate as well. So really large window and really low loss rate. So you think, well, it's perfect. If we want to reach the perfect state like that one, based on the current status of the TCP, can we achieve that one? No. So of course here we just want to have the conclusion. Well, if indeed you want to have the given throughput, so you should have a really large window size and you need to have a really low loss rate. So a new version of TCP is required. Well, we just want to let you know we have one possible formula, and the formula can be derived from maybe from one of the problem in chapter 3, and so that we have the current formula. Based on the current formula, it says impossible for the current requirement. Because of impossibility, so we need to have the new version of TCP. Alright, so this one we just want to let you know this. Well, so this is a summary of the current chapter. We then have the principle behind transport layer. So I think you know multiplexing, demultiplexing, Specifically, we emphasize reliable data transfer in general, and then we focus on flow and congestion control. After that one, in fact, we pass on TCP. Even we focus on TCP. Still, we mention some about UDP. Even UDP does nothing. However, sometimes we need to rely on UDP. For example, HTTP version 3, right? And finally, we then have the delay modeling of TCP slow start. In fact, we have TCP congestion control, but this one, we don't really know all the details for TCP version, TCP flow connection management, TCP flow control, and TCP congestion control. Well, so next chapter, we'll talk about all of these. So next one, actually, we will move to the network layer. And network layer, we have 2 chapters to discuss, chapter 4 and 5. However, almost so later I will let you know some of that. But before that one, ask you, sorry, this one. I'm not sure if this one okay or not. Check this one okay or not. Attendance check-in today. Okay, let me get back. Today maybe I think all of students come into the classroom, so it doesn't mean we need to really have the 2 minutes. Maybe we can shorten the time. Well, I can make sure not finish with your hands. No? Okay, 1. You can continue. Next Monday, perhaps we will change the classroom to the 4th floor. Once I have the information, I will post it on our line group. Alright, I will reserve 2 classroom, and the TA will disclose the classroom to you, and then you can find which classroom you should go. Alright. As for the other details, we will release properly. And check at least line group information for sure. So let me get back to this. So finally, this is the usual activity, self-reflection of chapter 3. And let me know your status, what you know, actually you understand well or learn well. So likewise, I use this one to have the reflection directly. Alright, the goal for you, refresh your mind. What you have in your mind, and then key so that I know it's okay or not. Go back, but we don't have any here. Yes, we talk about transfer layer. So we will focus on TCP, but before that one, we will have the general description. Maybe for most of you, you care about congestion. That's correct. We have the complete version for congestion, specifically TCP congestion. And yes, we try to control the window. So one mentioned, okay, you know the term CWND, and some talking about slow start. And because of a finite state machine, so we will have a timeout. And go back and, the slow start will have the facial setting. That's fine. Also, of course, we have RTT, and some of you mentioned selective repeat. So we have SR, we have RTT, we have the simple one, multiplexing. That's correct. That's all. So let me make sure for students in the classroom. Not finished for you. Okay, so finish for you. Then I can leave you, right? Alright, so let me close it and get back to this. So it's done for chapter 3. Alright, so let me have the description for this. So today we finished the discussion for remaining details of the transport layer protocol, including go back N, TCP, and also I did have some details about slow start if we want to change base from 2 to the other possible base. Of course, we finish all for using the reflection. So this is the wrap up for chapter 3, and that's it. And later we will have the quiz number 2. And that's all. So let me close it. And next Monday we have the midterm exam. Don't forget that one.